In our previous work, we solved some systems of two linear equations the hard way, and in doing so, we discovered the way to invert a 2 by 2 matrix. In this video, I'm going to show you how, by solving a system of three linear equations the hard way, you can discover how to invert a 3 by 3 matrix. So I'll start out by doing some linear combination of these equations. If I add to the first equation negative 2/5 of the second equation and negative 1/5 of the third equation, then those three equations add up to 7/5 x plus 0y plus 0z equals negative 13/5. Now that I've eliminated the variable, all I have to do is multiply by 5/7 and I get the answer x equals 13/7. So that's how I'm going to use linear combination. But that might not be satisfying to you. You might say, wait, how did you get those numbers negative 2/5 and negative 1/5? And the answer is, I can't tell you, it's a secret. No, I was just kidding. I'll show you a very nice way of seeing how you can get those numbers, thinking of the system as a matrix. So first of all, I'll put in the coefficients of 1 wherever we have coefficients of 1, and then I'll get rid of the rest of the equation, and we have this matrix multiplied by the 3 by 1 matrix x, y, z, and that gives us the right sides of the equations, negative 1, 1, 6. But in order to keep better track of the linear combinations, I'm going to actually move this over to the right, and I'm going to insert an identity matrix in front of it. It doesn't change the equation, but the identity matrix is going to record all of the linear combinations. And in the end, that will turn into the inverse matrix, just like we did with the 2 by 2 system. So I want to figure out how much of the second and third row to add to the first. Let's say I want to add alpha of the second row plus beta of the third row to the first row in order to eliminate the y and the z coefficients. How can I figure out what alpha and beta are? Well, I see that I need to multiply alpha by 2 plus beta times 1, and that has to add up to negative 1. So 2 alpha plus beta equals negative 1, and then similarly an alpha and a 3 beta has to add up to negative 1. And look what I have. It's a system of two equations and two unknowns. I could write this system in matrix form, and I see that I could actually solve this by using the easy method we found for inverting a 2 by 2 matrix. You see this 2 by 2 matrix, 2, 1, 1, 3, it comes from the 2, 1, 1, 3 part of our original 3 by 3 matrix. And then the negative 1, 1 on the right side of the equation, that's the opposite of the 1, 1, so that we cancel out the y and the z components. So now that I've expressed it as a matrix equation, I just have to invert the matrix 2, 1, 1, 3, and I can automatically find the values of alpha and beta by multiplying by the inverse matrix. And the result of the matrix multiplication is those two numbers, negative 2/5 and negative 1/5. They are the amounts that I multiplied the second and third row by to cancel out the x and y components of the first row. And when you get these numbers, you should check your work and make sure that you really do cancel the y and the z components. So when you multiply through and add, the first equation coefficients become 7/5, 0, and 0, as we saw in the beginning. And if you do the same thing to the identity matrix, you multiply the second row by alpha and the third row by beta and add it to the first row, then you get 1 alpha beta. Basically, you're recording the exact linear combination that you used to turn the first equation into this equation. And that's it. Now you have to do that 2 more times. So the second time you do it, you want to cancel the x and the z term in the second equation. So you'll need to look at the matrix 2, 1, 1, 3, and you'll have to find a linear coefficient of those two rows that cancel out the 1 and the 1, and the equation becomes negative 1, negative 1 times the inverse of 2, 1, 1, 3 equals negative 1, negative 1. We invert the matrix, we multiply it through, and we get negative 2/5, negative 1/5 for our next coefficients. So in other words, we're multiplying negative 2/5 times the first equation, and we're adding negative 1/5 of the third equation to the second equation. And when we do that combination, the second equation becomes 0, 7/5, 0. And then we do that to the identity matrix, and we get negative 2/5, 1, negative 1/5. And then we do that one more time. When this time we want to cancel the x and the y part of the third equation by adding alpha of the first equation plus beta of the second equation. So we're going to use 2, 1, 1, 2. And again, they have to add up to negative 1, 1 for this particular matrix. And the inverse of 2, 1, 1, 2 is found, and we multiply through, and we get negative 1/3, negative 1/3. And then at this point you check that that linear combination of the first two equations does cancel the x and the y components of the third equation, and we get 0, 0, 7/3. We do the same thing to the identity matrix, and we're now one step away from finding the inverse matrix. Okay, we've made the matrix a diagonal matrix. All we have to do now is multiply the rows by the reciprocal of their terms, of their non-zero terms, so that it turns into the identity matrix. So we just multiply through, and we multiply through on the other matrix, and we get our result. Now this matrix is the inverse of our original matrix. This is a pair of inverse matrices, and this is a good time to check. You should be able to multiply together those two matrices in either order, and you should get the identity matrix as a result. Once you're sure you have the inverse matrix, you can solve your system now by multiplying the inverse matrix times the 3/1 matrix, negative 1, 1, 6, and the result is negative 13/7, 1, 7, 18/7, and that, of course, represents x, y, and z. You have now found the values of x, y, and z, and of course, you should substitute them back into the original equations, and you will find that all of the equations are true, and hooray, we won! Okay, so now it's time for you to try one of these on your own. Here is a system of 3 equations. Try to follow the exact steps that I used in this video and see if you can find the inverse matrix associated with this system. And when you have succeeded at this, your mind will be ready to learn the fast way of calculating an inverse of a 3 by 3 matrix.